This lesson is on factoring special polynomials. If you see an example below that's similar to the current question you're working on, you can download my app referenced in the video caption and use it to quickly navigate all of my Math 10 lessons and examples. So you can use it to go directly to that example below that looks similar to the one you're working on. So special case number 1, and this is the main special case that it is very useful to memorize. Your teachers will often ask this kind of question in your test, or they'll slip it into a more complicated question, and it's very useful to have to simplify many questions you're given. Bottom line, please do memorize it. It'll help you out. A difference of squares is a special type of polynomial which is very easy to factor once a couple of steps are memorized. To learn this type, let's go backwards first. Let's expand x minus 1 multiplied by x plus 1. So x minus 1 times x plus 1, we get x squared, and then foiling it out, plus 1x minus 1x minus 1. It's very important to note that those middle terms, they cancel out. We can say that they cancel out. 1 minus 1, you're going to get a 0. So they go away, and you end up with x squared minus 1. This polynomial that we've ended up with is called a difference of squares, as it fulfills the below items. 1, the first term is a perfect square. X squared has a square root of x. The second term is a perfect square. 1 has a square root of 1. And both terms are separated by a minus sign. So difference of squares, difference means you have the minus sign there, and of squares, your first and second terms are both perfect squares. So this is how you can recognize this special case. If both numbers look like perfect squares and you're subtracting them, it is a difference of squares, and it's very easy to factor. So let's look at how to factor it. Example 1. Factor 4x squared minus 9. So you'll see that 4x squared has a square root of 2x. 9 has a square root of 3. And both of these terms are separated by a minus sign. To factor a difference of squares, write two sets of brackets. First, write the square root of the first number, so 2x, in the first position in each of those two brackets. Then, write the square root of the second number, of the 9, so 3, in the second spot in the brackets. And then, add a plus and a minus sign. So, the square root of the first, or positive term. Note, if this first number was a negative, it can't have a square root, so it has to be a positive number. This 3 is the square root of the negative term, the 9 here, and then one sign must be positive, the other negative, because when you FOIL this out, those middle terms will then cancel, as shown on the previous slides. Example 2, factor 16x squared minus 25y squared. So our numbers are getting a little more complicated, but you'll still notice, hopefully, that these are both perfect squares here. The square root of 16x squared is, look at the number first, the square root of 16 is 4, the square root of x squared is x, so the square root of this term is 4x. The square root of 25y squared, similarly, is 5y. And they are both separated by a minus sign. So this is a difference of squares. So, very easy to factor this now. Start with our two brackets. Put the square root of the first term in the first spot in each bracket. So the 4x here. Square root of the second term in the second spot, 5y, 5y. And what are our signs? A plus and a minus, so that when you FOIL that out, those middle terms cancel, and you are left with just the 4x times the 4x is 16x squared, and the 5y times minus 5y is negative 25y squared. Example 3. Factor 3x squared minus 3y squared. As always, check if there is a GCF, a greatest common factor, to factor out first. There is, in this case, the 3. So let's take that out. So we're left with just x squared minus y squared in the brackets. So this is a case that I wouldn't be surprised if you see one very similar on your test, and where you always need to check within brackets now, can you still factor that? And they love to insert a difference of squares after you've factored out a GCF already. So this is a difference of squares. The square root of x squared is x, the square root of y squared is y, and it's separated by a minus sign. So that will factor into our x's going in the first spots, the square root of the y squared going in the second spots, and then our signs are plus minus so that those middle terms cancel out. Example 4, factor 9x squared plus 9y squared. So as always, take out the GCF. In this case, it's a 9. So we factor that out. Now, can we factor this further? I hope you are saying no, because even though x squared has a square root of x, y squared has a square root of y, they are adding together. And so we cannot factor this further because there is not a minus sign between those two terms. It is not a difference of squares. So it is impossible to factor the bracketed part there further. So we're actually finished factoring this. So let's look at special case number 2. This one isn't as crucial to memorize because if you just factor a trinomial as you normally would, you would still kind of figure this one out. So example 5, we have factor x squared plus 8x plus 16. Let's factor like we normally would when a equals 1, which it does in this case. So a, remember, is the integer in front of the first term here. So it is just a 1. It's not shown because it's just a 1. So the two numbers that multiply to 16 and add to 8, that would be 4 and 4. So we have x plus 4 and x plus 4. And we can rewrite that as x plus 4 squared. This is a special case since it's written as a binomial squared here. We can simplify it quite a bit. This is kind of like the difference of squares, except instead of the middle terms canceling out, they add up. So think about it going backwards and you FOIL that out. We would have x times x is x squared, x times 4 is 4x, 4 times x is 4x, so that's 4x plus 4x, and you get your 8x. So those middle terms added to 8x, and then 4 times 4 is 16 there. So that's just what this is showing here. So because they're both positive signs here, they both add up and you get that 8x. Example 6, 2x squared minus 20x plus 50. If it exists, as always, factor out the GCF first. In this case, it is a 2. So let's factor that out. What's left in the brackets is actually another perfect square trinomial as it fulfills the below criteria. The first term is a perfect square. The third term is a perfect square and is positive. So note, the third term has to be positive and a perfect square in order for it to be a perfect square, fulfill one of the terms for it to be a perfect square trinomial. And the middle term is the square root of the last term multiplied by 2. So the square root of the last term is 5 times 2 is a 10, and that could be a positive or a negative 10. But the last term has to be positive. Middle term can be positive or negative. And again, note that you don't really need to memorize this case, as if you factor like you normally would, you would still get the right answer, like in example 5. So I don't spend too much time on this case. But it is good to know. You are technically taught it. You should know what it's called. So continuing that example, if we factor this as we normally would, the square root of the first guy there is xx, and then the two numbers that multiply to 25 and add to -10 are -5 and -5. And we can rewrite that as x minus 5 squared. And again, both of those signs have to be negative to go to the -10. This could be a perfect square trinomial if it was x squared plus 10x plus 25. All you would do is change both of those signs to be positive. Example 7, 2x squared minus 28x minus 98. As always, factor out your GCF. So we take out our 2. Now, is this a perfect square trinomial? Can we factor this? This cannot be factored further, since there are no two numbers that add to -14x and multiply to -49. Try to think of two. I will give you $1 million if you can. You won't be able to. A perfect square trinomial always has a positive third term, since the middle terms will always multiply to be a positive number, as they will either both be negative or both be positive. So, you could have -7 minus 7, which is what you need in this case to get to -14, and you would end up with positive 49 when you FOIL that out. Or you would have plus 7 to be a plus 14x, and then multiplying those two, again, you get positive 49. But you can never have a -49 here and a negative term here for a perfect square trinomial. So don't freak out if you can't factor this further on a test. You can just say to yourself, no, there are no two numbers that will multiply to -49 and add to -14. So last slide here, and this is very important to memorize when factoring any expression. We've now looked at how to factor any type of polynomial expression. Follow the below steps when factoring any of these expressions. 1. Is there a GCF, greatest common factor, among all terms? If so, factor it out first. Next, is it a special case? This will help you do the question a bit quicker sometimes. And if it's a difference of squares, which they like to put in a lot, you definitely want to catch that one, because it's not as obvious actually to factor that out like you normally would. You actually need to recognize it. Two perfect squares, and you're subtracting them from each other. So if you didn't quite get that, make sure you go to the beginning of this lesson again and memorize how to recognize the difference of squares. I guarantee you will still see that in higher grades. Step 3, ask yourself, is it of the form ax squared plus bx plus c where a equals to 1? If so, factor accordingly. This is the easier type of trinomial to factor. So if it's not that, is it of the form ax squared plus bx plus c where a is greater than 1? Is the integer in front of your x squared term greater than 1? Is it a 2, a 3, a 4, etc.? If so, factor accordingly. So you're either going to factor by grouping or by slide and divide, and that is shown in part 2 of the lesson on factoring polynomials. By now, you should be fully factored, but it's always best to check if anything else can be factored within the bracketed parts. There can sometimes be a very simple looking difference of squares left within brackets, like an x squared minus 1. So watch out for that one. They could put an x squared minus y squared into there. Something very harmless looking, but it is factorable. So that would factor, this one would factor to x plus 1, x minus 1. Also check if there are any GCFs within bracketed parts in case you missed factoring out the actual greatest common factor at step 1. You could have factored out a common factor, but if you didn't do the greatest common factor, that would carry through to your final row of what you think is your answer. So it's always good to double check. Is there still a factor in there that you can factor out?